Hello, my name is Dan Bursani, a biomedical engineering student from Ryerson University, and today I will be explaining the use of our Sick Kids Navigator app that was coded and prototyped at WareHexTron 2016 for the Sick Kids Challenge. The point of this application is to help a patient get around the Sick Kids building. Before I begin this demonstration, I'd just like to say that this application was coded in Xcode in the Swift language and is made for the iOS line of devices. I'd like to begin by saying we have a Sick Kids Navigator login and portal page, which just is used to track the patient's appointments and any sort of other information like feedback responses as well. I will be giving a quick demonstration and will be using my email address as well as creating a username and password for this portal. Please note that for password security we have set it for greater than 8 characters. And this sign up backend was created in Parse and can be tracked. So I'll just be putting in a quick password, be signing up, and as you can see the sign up works perfectly, and we just like to say that the main purpose was for the user or the patient to implement the location feature, which can be used with the patient session ID. So we would like the hospital to create a unique patient session ID, which will pretty much pinpoint the location of the appointment in the hospital. So when the user puts this patient session ID into the application, it will locate on the PDF map where exactly the patient needs to be for this appointment and any other prerequisites such as forms that need to be completed. So this is just a quick demonstration of our sign-in login portal. We also at the end of this application have a quick survey that is powered by MailJet that will just be used for data collection and other purposes such as feedback. And this is perfect for the hospital to just collect information on how its patients are feeling about different appointments. We are then going to switch on over to the Beacon Navigator application, which is the main application that we have created. It uses the Estimotes Beacon's location and accuracy to allow the user to determine where he is in the hospital as well as where he needs to go, with the goal being real-time tracking. So as you can see, we have a beacon list, and on the beacons list it's just going to display all the beacons that are nearby to the patient. Right now I do not have any beacons in place, so it does not show anything. It's just used to track how many beacons the individual has around him, and it's just a sort of tool showing that the beacons are listed and there is no fault. Next, we have a settings application, which just displays the different algorithms used as well as the beacon's accuracy and how many beacons are nearby if a filter needs to be placed. The settings is just there so that if there are any difficulties with the application, we can tweak with the settings just to fix the location for the patient or the individual using the application. Next is the most important part, which is the indoor navigation. And so in the indoor navigation, we have a bunch of maps loaded. We have a test map, Sick Kids map, and simple map. These maps can be divided upon the blueprint of the building. For example, for the Sick Kids application, we can have it for different zones. But just for this purpose, we took a blueprint PDF that was found online as a demonstration. When we click the Sick Kids map, we have a generated PDF. The red part is the start, the red dot is the start, and the red star is the endpoint. And as you can see, all the black dots or buttons that are seen on the walls are the beacons located. And we just like to start off by saying the beacons automatically generate a very good algorithm for the patient to follow in order to get to his or her appointment location. And so the algorithm followed was a straight line up followed by a straight line down the right, which will go straight to the star. So it starts at zone 3 and goes to zone 5, and this algorithm can change according to the user's preference. This is a general algorithm that was created. We also have a calc position, def position, and deviation, which just shows the exact accuracy of where the person is located. Due to the PDF being a very small image, we weren't able to fully upload the image, and that's why there's a lot of white space on the display, but our goal is to get a very high quality PDF to create a very nicely generated map. We also have a very important feature, which is the track feature and untrack feature, which traces the user's steps. And one of the main and very important features we have is the generate PDF button on the top. This allows the user to take a screenshot of the map and send it to any person that he or she wants to share it with. This is perfect because if a patient wants a visitor, like for example his mom or dad, to visit he or she, they can just take a screenshot and share it to them, and the other person who receives the screenshot will know exactly where they are located and how to get there, which pretty much frees up a lot of time. So we can share it to mail, WhatsApp, iMessage, AirDrop, and copy print. And this is probably one of the main features of this application. We hope you enjoyed this demonstration and we hope to implement this application. One of the main goals of this also is to create real-time feedback, which will allow the user to real-time track his distance. Thank you very much and hope you have a good day.